Hello all, good evening. Today we will discuss about gears and gear trains. Right. So first, first let us start with gears and gear trains. So gears are generally used to reduction in speed and increase in torque. Right. So gears are used generally for speed reduction, and you can get increased torque because your power will be given by this t omega, right? So when power is given by t omega, then t into this omega is 2 pi n by 60, right? So when you will have pair of your gears, then you will have t1 omega 1 is equal to t2 omega 2, right? So when you will again elaborate, it will be t1 into 2 pi n1 by 60, right, equals to t2 into 2 pi and 2 by 60. So when you will give further simplification, it will be t1 n1 is equal to t2 n2, right? So here when you have reduction in speed, right, then you will have increase in torque. So this is how generally gears are used for this speed reduction and in order to get higher torque, right? So if you first simply see this figure here, this figure represent actually friction wheels, right? So where the 1 and 2 both are rotating without slipping, right, without slipping. When it will rotate, it will transmit power from the driver to driven. Here driver we are considering as this 1 and driven we are considering as this 2. So it
Hello,
will,
sir.
sorry, hello,
Sir, voice not audible, sir.
hello, can you hear me?
Hello, sir. Yes, sir, but volume very low, sir.
Okay, now is it clear?
Yes, sir.
Okay.
Thank you, sir.
Okay. Thank you. Yeah. So here it will rotate without slipping. So because of friction, power will be transmitted from the wheel 1 to wheel 2, right? So here if you consider a point P, as it is mentioned here, this linear velocity of point P is mentioned. So if you consider point P on wheel 1, then it will have linear velocity omega 1 r1, and when you consider that point P on wheel 2, it will have linear velocity omega 2 r2. Both are equal, right, because it is of the same point. So omega 1 r1 is equal to omega 2 r2, right? So here also when you further simplify, you will find this 2 pi n1 by 60 into r1 is equal to 2 pi n2 upon 60 into r2, right, which will give you this omega 1, or we can say, sorry, first you can only write like this n1 into r1 is equal to n2 into r2, right? So you can even further simplify it. N1 by n2 is equal to r2 by r1, right? So now this is how you are having your speed reduction and increase in the torque when you are going to use this gears. See here, what we have seen is friction wheels, and here you are having the rotation of wheel without slipping. In order to ensure the more exact positive drive, you can provide a tooth or teeth on this wheel, right? So that toothed wheel, in order to ensure that positive drive, right, with exact velocity ratio, that particular toothed wheel is known as gear, right? So this is how you will have your gears, right? Now if you see the classification of your gears, then based on the axis of the shaft on which they are mounted, they are classified as this different types of gears, right? So here the first is this spur gear. When you are having your axis parallel, right, both the axes are parallel and not intersecting to each other, so you can see the gears mounted are on the parallel shafts. So here the figure A shows the external gear, right, external spur gear, while here you are having this internal spur gear, right? And the below figure shows the helical gear, right? Helical gear are having their teeth inclined at certain helix angle, right? As per that it is having that inclination. So this is how you are having your this parallel shafts gear, right? One more type is there, in that you are having this rack and pinion, right? Rack and pinion, where this particular component is pinion, while this particular what we can say, a shaft with infinite radius which you are seeing is known as rack. So this kind of gear pair is used to transmit one type of motion into other type of motion, rotary motion to translatory or translatory to rotary. So this is how you are having this different types of gears. Here in this helical gear, if you are having this double helical gear, right, means in the same gear you are having different helix angle, right? So why this kind of gears are used is in order to nullify the thrust generated in the helical gear, right? So it will what we can say, nullify the thrust, right? It is also called herringbone gears, right? This particular double helical gear are also called herringbone gears, right? While you are having non-parallel, non-intersecting shafts, then you can have this worm and worm wheel. These are having very high gear ratio, right? While this is crossed helical gears, right? And these are hyperboloid, means hypoid gears, right? So these are various types of gears, right? Here you are having that non-parallel and intersecting shafts also. These are parallel and non-intersecting. These are non-parallel and non-intersecting. Sometimes you are having this non-parallel and intersecting. In that you are having your bevel gears. Your figure is not mentioned, but bevel gear are that kind of gears, in that you are having mitre gear when your axis of shafts are intersecting each other at 90 degree, right? In that particular case you are having this mitre gear. It is a special type of gear which is used in differential gearbox. So this is how you are having this different types of gears, right? Once you know about various types of gear, then this gear terminology is also important, I guess, and I will not spend much time on this because these are very basic terms you must be knowing about this gears, right? Pitch circle is the imaginary circle, right, which we are assuming that at every time this pitch circle of both the gears are in contact with each other, right? Whenever you are having two mating gears, right, here you can see actually it is already mentioned here. I need not to draw this actually, right? You can see here every time this pitch circles of the mating gears are in contact with each other, right? So this is how you are having that pitch circle. Then this space, width, tooth thickness, all the things are measured along the pitch circle, right? Space width is the space between two adjacent teeth. Tooth thickness is the thickness of a particular tooth measured along the pitch circle, right? Face and flank are also mentioned. This top line, bottom line, all these things are clear from, I guess, whatever from the geometry only, right? Now apart from pitch circle you are having addendum circle and addendum circle, right? So addendum circle, pitch circle is having two different this particular tooth is having this addendum circle and dedendum circle. And when this addendum circle is passing from the tip of tooth, right, top of the tip of every tooth of your gear, and while this dedendum circle is passing from the base of your every tooth of your gear, right. Whenever your two different gears are in mesh with each other, you must have to provide this clearance, right. That is why this clearance is provided. So your addendum and dedendum both cannot have the same magnitude. If the both will have same magnitude, then you will have interference and jamming, and also in order to avoid all this, you have to provide this clearance, right. So apart from that, one important thing is this pitch circle diameter, right. Pitch circle diameter is mentioned here, right. So how you are going to get this pitch circle diameter is from the module and number of teeth, right. So basically module is defined as this diameter upon this number of teeth, right. And this all the specification of gears are generally in terms of this module only, right. And this module has also come from diametral pitch. Actually, diametral pitch is also an important terminology, where you are having this number of teeth divided by that pitch circle diameter, right. So this diametral pitch will give you that whatever number of teeth divided by this pitch circle diameter. So how many number of teeth are there in a particular length, that will be provided by this diametral pitch. But as you can see, the unit of this diametral pitch is coming mm inverse. So in order to have what we can say uniformity, they have termed this new terminology or new word as module, and new particular dimension, this t by t, right. So this is how you are having this diametral pitch and module. These are also important, right. And your this circular pitch is given by pi d by t, right. So that is nothing but pi into m. So these are some of the important things you have to keep in mind, right. While here some of the other important things are mentioned, like path of contact and this pressure angle and all these things, right. This we will actually derive path of contact, how this whenever your two gears are in mesh with each other, that what is the total distance traveled when one tooth is engaged to another tooth and it got disengaged. So during that, what is the distance traveled, that is the path of contact that we will derive, right. So this is how you are having your different gear terminology, right. Now if we go to this law of gearing, yes, yes,
sir, the working depth from clearance circle to addendum circle, na?
sorry,
Working depth from which point to which point we have to consider the working depth.
Working depth must be from if you consider another gear in mesh, right, then here that other gears what we can say, one second. See, if you are having another gear in mesh with this particular gear, then here you must be having some clearance, right, between this one. This must be the clearance, right.
Okay, sir.
Right. So what happens is, from here you will have, this can be as the dedendum, right, like this your other teeth of the gear 2 will be there, right, and you can consider this as gear 1. So this is the base circle, and or what we can say that dedendum circle, right? And this can be your this circle which is in contact with the addendum circle of the other gear, while here this can go up to this clearance actually, right? Are you getting? Right here,
Yes,
this is clearance, so up to this point it can go. So this particular circle is addendum circle for the mating gear,
okay, the for the other gear.
correct?
Yes.
Right, so this is how you are having this clearance circle and working depth and all, right? Now
Means from in the radial direction, it is from the clearance circle to the addendum circle of the other gear.
yes, okay. So now if we go to this law of gearing, right, then what law of gearing says is, see, what we have assured is whenever you are using your this gear drive, your velocity ratio omega 2 by omega 1 will remain constant all the time, right? That is why we are using this particular gear drive in order to have exact transmission of motion with exact velocity ratio, right? So now what law of gearing states is, whenever you are having this gear in operation, the common normal must pass through the pitch point, right? So here this P is the pitch point, right? Here this is your gear 1, this is your gear 2, right? This gear 1 is having rotational velocity of omega 1, and gear 2 is having that omega 2 of rotational velocity, right? So with this, if you see here, this is a common tangent, right? This TT is the common tangent, right, which is having point C on the gear 1 and point D on the gear 2. So this is the same point actually. Basically this point is the same point, right? We are calling it C on gear 1 and calling it D on gear 2. So this TT is the common tangent, right? And when you draw a perpendicular to that common tangent, that NN, that is your common normal, right? So NN is common normal and TT is that tangent at the point of contact. Now this A and B are the centers about which these gears are rotating, right? So if you think of this velocity of point C, right, then for gear 1 it will be perpendicular to this AC, right? So this VC is the velocity, as you can see in the figure. VC is the velocity with respect to A. And similarly, if you think about the point D, which is on this gear 2, then it will be perpendicular to this BD, which is known as here, shown as VD, right? Now the both velocity VC and VD you are having, right, along with the angles they are making to the common normal, right? So once you have this, then what you can do is, your this particular velocity along the common normal for this VC is VC cos alpha, right? And in case of D, it is VD cos alpha, right? Now if you consider that relative velocity VC cos alpha minus VD cos alpha, in order to check whether this point is having any penetration, vice versa, either point C into that D or in the gear 2, or point D into gear 1 or towards the C. So if you check this with this relative velocity VC cos alpha minus VD cos alpha, then it must be 0, right? Because there must not be any motion or relative motion towards the common normal, otherwise penetration will take place, which will result in the undercut, which will result in the cutting of the gear tooth from the base, right? So this is how this VC cos alpha minus VD cos alpha must be 0, right? So now what is VC? if you calculate VC, then it is nothing but this linear velocity is nothing but this rotational velocity into the distance. So that is omega 1 into AC. VC is omega 1 into AC. Now cos alpha is nothing but AE upon AC, right? This triangle, if you take ACE, right? So in that, this cos alpha is nothing but AE upon AC, right? Similarly, if you go for D, then it is omega 2 into BD. And similarly in that triangle BFC, if you BFD, if you find that cos beta here, so it is cos beta, right? So cos beta is nothing but BF upon BD, right, is equal to 0. So once you have this, then you can have this omega 1 AE is equal to omega 2 PF, right? So now you can write omega 1 by omega 2 is equal to this BF upon AE, right? So which can also be written as BP upon AP, right, from the similar triangles. And furthermore, it can also be represented as omega 1 by omega 2 is equal to FP upon EP. So once you represent it in this particular form, then it is nothing but your law of gearing. So if you see here, this FP and EP means whenever you are having any point of contact, your velocity will be always be rationalized with this particular point P, right? So if you are telling this right, so itself it says that whatever law of gearing is there, that is common normal must pass through the pitch point at every time, then only you will have this exact velocity ratio. So this is how you are having your law of gearing. Now one more important thing is, as you have taken your components of velocity along the common normal, if you will take your this component of velocity along this tangent, then you will have velocity of sliding as it is mentioned here, right? So in order to calculate that velocity of sliding, what you are going to do is, you are going to consider those components which are along the tangent. So let me first rub this, and then we will also find velocity of sliding. So 1 second. So in case of this velocity of sliding, what you are going to do is, you are going to consider that Vc sine alpha minus Vt sine beta, right? That is your velocity of sliding. So what is Vc? That we have already seen, right? Omega 1 AC. Now sine alpha will come EC upon AC, right? If you check in that same triangle, then it will be EC upon AC. Now this Vd sine beta, in that Vd can be written as omega 2 Bd, as we have earlier also mentioned, and sine beta is given by Fd upon Pd. So if you further simplify, you will get omega 1 EC minus omega 2 Fd. Now EC can be written as EP plus PC, right? Omega 1 EP plus PC minus omega 2 Fd can be written as Fp minus Pd. Fp minus Pd, right? Now if you see, this omega 1 PC and omega 2 Pd are coming positive, right? Omega 1 EP plus omega 1 PC minus omega 2 Fp plus omega 2 PD. Now PD and PC are same basically, because this point is same, na, C and D, as we have considered. So you will have basically omega 1 plus omega 2 into PC plus omega 1 EP minus omega 2 FP. Now as we have derived law of gearing, omega 1 FP is equal to omega 2 FP, right? So it will be 0, right? This will cancel out and it will be 0 because omega 1 EP is equal to omega 2 FP. So what we left with is omega 1 plus omega 2 into PC. So this is nothing but velocity of sliding, right? Now how can you interpret this? See, omega 1 plus omega 2 are
Sir,
the
excuse
rotation.
me?
Yes.
Sir, please explain how omega 1 EP equals omega 2 FP.
See, just now we have derived that if you have I don't know whether you will be able to make a note of it or not, but if you have screenshot of that one, then also you can check that omega 1 EP is equal to omega 2 FP. That is what we have just now derived in law of gearing. Okay.
Okay, sir. Okay, sir.
Okay. So omega 1 plus omega 2 into PC. Now PC is what? It is the distance between pitch point and the point of contact, right? As you can see here, PC is nothing but the distance between the point of contact and the pitch point. So this is how velocity of sliding can be given by both the rotational velocity of the gears 1 and gear 2 into this particular this distance between pitch point and the point of contact. So this is how you are having your velocity of sliding. So if you further go for the path of contact, right, then in that particular case, if you want to calculate the path of contact, then you have to assume your two gears here, A and B, right, are in mesh with each other.
Analysis of a gear, sir.
Sorry.
Sir, it is a force analysis of a gear, sir.
No, this is not force analysis. Right now we are not calculating force. We are calculating the basic parameters, and this path of contact and arc of contact and contact ratio will tell you what are the number of teeth in contact at a particular point of time. So we are calculating and we are checking this particular things in a gear drive for now, right? So it is very basic of this gear drive. Okay, so let us continue with this. So here path of,
Excuse me, sir.
yes,
I have one doubt. So what is the difference between pitch point velocity and sliding velocity?
sorry,
So difference between velocity at the pitch circle and velocity of sliding
velocity at,
pitch point and velocity of sliding. How to differentiate between them?
I guess velocity at pitch point. Can you tell me what can be the velocity at pitch point?
So R into omega,
Sorry.
radius into angular velocity.
See, from this particular what we can say, this equation, what are you asking is this velocity at pitch point, then distance from the, if the pitch at particular I guess at pitch point, if the distance from the pitch point is this, how it will be 0 now, or you can double check, I guess, because here velocity of sliding is omega 1 plus omega 2 into the distance of contact point to the pitch point. So if you go for velocity of sliding for pitch point, then what will happen? Are you getting what I am trying to say?
No, sir, exactly. Sir, you in the
It will
previous
be more
2
clear.
minutes ago, you
It will be
mentioned
more.
that
Yes.
velocity at the point of contact of two meeting gears is constant for both of them,
Yes.
and another velocity is velocity of sliding. Means,
Yes.
they are both same or different.
They are different. No?
Yes, sir. I am not visualizing how velocity of sliding is. So what is the distance over which the slides
See, that
path
will
works.
that will be, I guess, more clear when you have idea about the path of contact,
Okay, sir.
right? So whatever we are going to see now, I guess it will be more visualized to you that how this velocity of sliding and for what this velocity of sliding. So first you have to have idea that when two teeth are matting with each other, how they are passing, right? So that will be
Okay, sir.
more visible in this path of contact, right?
Okay.
So let us see path of contact. So as I have told you here, your gear A and gear B are in mesh with each other, and as you can see here, you are having that point C, right, is the what we can see is the addendum of this wheel, right, or your gear, right? We are having gear and pinion, right? So this gear is having the point C at its addendum, right? While if you see for that pinion, which is A, for that it is at the, I guess, the it is besides this dedendum circle, right? If you avoid this clearance, then it is besides this dedendum circle, right? So actually, if this particular A is the driver and B is the driven, right? So if A is driving, then A is how first it's this dedendum point, right, will be in contact with the addendum of the driven. So this is the point C, right? Similarly, if you see, it is passing through this pitch point. This pitch point is the point which is always in contact, as we have already discussed, right? And this particular what we can say, this point C will travel through this point D, right? While at point D you can see it is nothing but the tip of that particular teeth which is on driver. C is beside the clearance circle towards the dedendum of this gear A, and D is nothing but the top of that particular same tooth, right, which has started engagement at point C, right? So C is at the base, or we can say towards the dedendum, considering this clearance for this pinion which is driver, right? And D is nothing but the tip of that same tooth which is in contact with the other tooth of the gear, right? If you see from the point of view of the gear, then what is happening is, as you can see, this particular circle is addendum for gear, right? This particular circle is addendum of gear, and here it is pitch circle of this gear, and here at this particular point of contact, right, if you draw another, as here it is mentioned, right, here if you draw another circle, or we can say for this gear only, then it is towards the dedendum, right? This is dedendum for gear, and this is nothing but the clearance, right? So this is how you are having this particular point F is on that base circle of your gear, and this particular point E is on the base circle of pinion, right? You can say this as pinion, right, and this, as you can say, gear. Pinion is your driver, right, and pinion is driven. So once you can visualize this, then I guess we can go forward. So this thing must be clear, that how pinion's teeth is having this particular point C at the bottom and D at the top of the same teeth. Similarly, this gear has D at its bottom and C at its top, right? Addendum of gear is here. So this is how, once you have to have this idea. So if you have this idea, then your path of contact, as it is mentioned here, is nothing but CD, right? CD is your path of contact, right, which can be clearly written as CP plus PD, as you can see in this geometry. Right here it is more clear, right? So you can see that CP plus PD is your path of contact, and here you can see this pressure angle phi is given for both the gears, and this RA is the addendum circle, as I have mentioned, right? RA is the addendum circle for pinion, right, or addendum circle radius for pinion, and RA is addendum circle radius for gear. So here this at point C it is the tip or top of your gear, and at point D it is at the top of your pinion. So this is how you are having this CD, right? So now if you find this CP and PD, then it can be written as CF minus PF, CF minus PF, and PD can be written as DE minus PE. Right, so you are having the CF minus PF plus DE minus PE. Now CF, how will you find CF? Right, here this is your CF, this distance is CF. So if you consider the triangle BFC, if you consider the triangle BFC, then in that triangle, that CF is nothing but RA square minus R square cos square phi, right? Because here you can see RA, this is RA, right? BC is RA and BF is R cos phi. So CF is BC square minus BF square. So RA square minus R square cos square phi. So this is how you are having your CF. Similarly, this PF, what is PF? If you see here, actually this P is not that visible. Let me have this. Now if you see what is PF, so this PF is nothing but R sin phi, as it is mentioned here only, right? R sin phi. So you are having this, I am writing this here, right? Now the CD is equal to this CF is nothing but RA square minus R square cos square phi, right, minus this R sin phi. Now as you have written this for your this gear, similarly when you write for DE and PE, right, for your this pinion also, you will find it in a similar way, right, that DE is nothing but RA square minus R square cos square phi minus R sin phi, right? So this is how you are having your this particular path of contact. If you further simplify, you can write it like RA square minus R square cos square phi, right, plus RA square minus R square cos square phi minus R plus R sin phi. So once you have this, then you can calculate this what we can say path of contact. If you see or observe clearly, then this particular CP is achievable from all the data of your gear, and this particular PD is can be calculated from the data of your pinion. So this is how you are having your path, what we can say path of contact. In this path of approach and path of recess is there actually. So path of approach is the CP and path of recess is PD. So path of approach means engagement starts, right, and then path of recess means that disengagement will start. So this is how you are having your path of contact. So from this path of contact, actually arc of contact also you can calculate, right? For that you have to consider tangential velocity and time of approach and all these things you can consider, and you can come up with the arc of contact as equal to path of contact divided by pressure angle, right? Cosine of pressure angle, cos phi. So this is how you are having this path of contact and arc of contact. Now apart from this, one more important terminology is there that also I am going to mention, right? So that is your contact ratio. As I have told you, you will have to have idea that what are the number of teeth are in contact at a particular point of time. So that is your contact ratio, or number of teeth in contact, right? So contact ratio is nothing but your arc of contact divided by your circular pitch. Circular pitch we have just now discussed, right? Pi d by t. So this is how you are having this contact ratio. Means arc of contact is, as we have discussed, is can be available from path of contact divided by cos phi. So once you have that arc of contact with you, it will give you a certain amount of length of your that pitch circle diameter of gear. So basically, if you try to understand it this physically, this arc of contact means particular amount of that base circle diameter is in contact with a meshing gear, and circular pitch gives how many teeth are there in a particular what you can say arc, right? So once you have that total amount of engagement, and you are going to divide it with this circular pitch, it will give you idea that what are the total number of teeth are in contact with each other, right? So this is how you are having your path of contact and arc of contact, and then this nothing but this contact ratio, right? Now next is interference. So if you have observed this particular thing, right, then in the previous calculation what we have done, there is one thing mentioned in this figure, and that is this RA max, right? So if you focus on that particular thing, what it says is, if you are having your addendum of this gear more than this mentioned what you can say distance BE, then what will happen? See, from here to here, right? BE, right? So right now your addendum is BC, addendum radius is BC, right? If you have your addendum radius as BE, then it will touch this base circle of your pinion, right? Because here it is crossing this clearance, right, whatever you have provided, and it is meeting at the base circle if it is BE. Now if it is more than BE, then it will start penetrating in your pinion. So that is known as interference. So in order to avoid interference, you must have your this particular what we can say addendum or maximum addendum is BE, right? It should not be more than that. So in order to calculate that minimum number of teeth required in order to avoid interference, we are going to again consider this figure, right? And in this figure, if you take your this triangle BFE, right, then you will have this BE square is equal to BF square plus FE square, right? So this particular for this, in order to avoid interference, right, whatever minimum number of teeth are required can also be calculated from that previous figure only. It is nothing but BE square is equal to BF square plus FE square. Now this BF can be written as it is, but Fe can be further written as Fp plus Pe square, right? So if you see what is Bf, Fp and Pe in the previous figure, right? So what is what is Bf? Bf is r cos phi, Fp is r sin phi, and Pe is that small r sin phi, right? This Fp is related to your gear, and this Pe is related to your this pinion, right? So if you have this particular geometrical data with you, then what you can do is you can find out the minimum number of teeth required, right, in order to avoid interference. So here it is r cos phi square plus r sin phi plus small r sin phi whole square, right? So once you have this, and if you are going to give simplification, then your BE can be written as r under root of 1 plus r by r, right, and further r by r plus 2 into sine square phi. That is your BE. Now if this is your BE, then your maximum addendum can be written as BE minus pitch circle radius. That BE you have calculated, right? That is the same, this r1 plus r by r plus 2 sine square phi minus r pitch circle radius, right? So maximum addendum can be calculated from this. Now if you put this r, capital R, is equal to mt by 2, right? Now from where this has come, r is equal to mt by 2 has come from that m is equal to d by t, right? So m is equal to d by t, so d is equal to r by 2, so r is equal to mt by, sorry, t by d, I guess, yes, t by d, right? So when you put d is equal to 1 second, that pitch circle diameter is pi m, right? And that is nothing but pi d by t. So m is equal to d by t only, right? So from m is equal to d by t, d is equal to 2r, right? So when you put d is equal to 2r, you will find that r is equal to mt by 2. So from that, this r is equal to mt by 2 has come. So here capital R and capital T refers to the gear, right? Similarly for pinion, it is small r and small t, right? This capital T and small t refer to the number of teeth on gear and pinion respectively, right? So this is how you are having your this capital R, small r and gear ratio capital T by small t. So once you put all this value in this equation, right, this maximum addendum, then you will find that maximum addendum is coming as mt by 2, right, in bracket 1 plus 1 by capital G, 1 by capital G plus 2 sine square phi minus 1. So this is how you are having your maximum addendum. Now if you consider any of the what we can say multiplier of module, right, to your this particular gear which you are manufacturing, so it must be actually satisfying this AW into M. AW is any what we can say constant which your manufacturer is using and multiplying it to module in order to generate your addendum circle of your gear, right? But this AW max must be greater than or equal to this AW into M, then only you can avoid interference. So if you go for further simplification, then you can have your minimum number of teeth, right, from this, right? Minimum number of teeth from this means T must be greater than or equal to this 2AW divided by 1 plus 1 by G plus 2 sine square phi minus 1, right? So this is how you can have your this minimum number of teeth, right, on your gear. So if you go for your this pinion, right, so for pinion also you will have the same calculations and all, and in that what you will find for your pinion is this AP max, right? AP max will be AP max for your pinion can be written as this MT by 2 in bracket 1 plus G, so 1 plus 1 plus G plus 2 sine square phi minus 1, right? So this is how you can calculate this also, and further you can also have this minimum number of teeth on pinion also from this, as we have calculated for gear. Now if you go for rack and pinion, then you have to be little bit careful, because for that it is not this simply as we have calculated for this spur matting spur gear, right? For rack and pinion, what you have to do is you can see this figure now. In order to calculate for rack and pinion, is this particular matting gear and rack is there. Second, let me rub this. So in that case, what you have to consider is, first again you have to go for this that GE, as we have gone for BE in that case. First of all, you have to consider this particular figure in order to see how you can calculate those things which we have calculated for spur gear. If you go for this rack and pinion, then here your GE, if you see, this is your GE, right? So your GE is PE sine phi, right? If you see in this triangle, your GE is PE sine phi. Now PE, if you see this PE, then this PE is again this R sine phi, because this is R, right? As here it is R cos phi, here this PE is given by R sine phi. So you can write this PE as R sine phi, right? And again that sine phi was there. So what you are having, GE is R sine square phi, and R is nothing but MT by 2, right? As we have written, MT by 2 sine square phi, that is GE, right? Now this GE must be greater than or equal to this ERM, as we have done previously. So here also if you do the same, then this MT by 2 sine square phi must be greater than or equal to ARM, which will result in T is greater than or equal to this 2 AR upon the sine square phi, right? So this is how you are having this minimum number of teeth on your rack, right? So this is how you can find it to avoid interference in rack and pinion also. Now path of contact, if you see for this rack and pinion, then path of contact for rack and pinion is CP plus PD, right? So again CP, here this CP can be calculated from your addendum of rack divided by cos phi, right? Plus this PD is nothing but, again, as you have calculated for your previous pinion, so it is same as that one only, that is RS square minus R cos phi whole square minus R sin phi, right? So this is how you are having path of contact, right? And again maximum path of contact to avoid interference is DE only, right, from here to here. If it will be more than that, then again interference will start. So if you see the maximum path of contact to avoid interference, then it will be DE, right? And DE is nothing but RS square minus R square cos square phi. So this is how you are having this different important terminologies and important things required, right, for your gear drive, right? So now once you are done with this, then here again undercutting is there. It is to avoid interference, right? As you can see, if you are having the same gear matting with each other, right, then one of the gear can go to the base of the other gear and it can have that interference. So in order to avoid interference, you have to cut it from the base, right? So that is known as this undercutting. Sometimes it is very what we can say difficult, because when you are having small gear and you go for undercutting, then it becomes weak. So sometimes it is difficult to go for undercutting, but most of the times undercutting is provided to avoid interference, right? Now there are different what we can say profile used to make this gear teeth, right? So these are the two most studied and what you can say discussed this profile for making gear tooth, cycloidal and involute, right? So here in cycloidal tooth, you are having pressure angle varies from maximum at the beginning of engagement and reduces to 0 at the pitch point, and again increases to maximum at the end of engagement, resulting in less smooth running of gear, because in involute you are having constant pressure angle throughout the engagement of teeth, right? One more thing is regarding this manufacturing of this cycloidal teeth. So when you manufacture cycloidal teeth, it involves this double curve, right? So that makes it complicated and difficult to manufacture, while in case of involute it is a single curve only, right? So it is having simplicity in manufacturing this kind of teeth. Now then in cycloidal teeth, you are having this exact center distance, right? So actually requirement is there, as it is mentioned, you have to have exact center distance when you are transmitting with this cycloidal teeth gear, means whatever gears are manufactured with this cycloidal profile, when they are transmitting the power, it must be this center of those shaft must be at exact distance. There should not be any deflection, while in case of involute little bit of that deflection is allowed, right? So this is how you are having this differences between the cyclodal and involute teeth, right? So once you have this different terminologies and different important aspects of gear, then we can go to this types of gear train. So types of gear trains are, you are having this simple gear train, then this compound gear train, then this reverted gear train, and then this epicyclic gear train. Now if you see this different types of gear train, then this gear trains are used to transmit power, right? So sometimes it is not possible to have distance within the vicinity. So in order to have some distance, you have to provide intermediate shafts for transmitting power from one shaft to other shaft. So here in the first case, it is transmitting power from the shaft 1 to shaft 5. So while transmitting power, what happens in this simple gear train is, when it transmits from 1 to 2, what will happen is N2 by N1, right, will be equal to T1 by T2, right? Similarly, when it will be transferred from 2 to 3, so N3 by N2 will be equal to T2 by T3, and it will go up to this N5 by N4 equal to T4 by T5. Yes.
So it's the PPT available, sir.
Yes.
Um,
Yes. It will be
how,
made available, right?
sir,
So
how can I access?
sorry,
How can I access this class PPT?
that I will let you know. Now this recorded lectures will also be available, right? So this PPT will also be made available. So don't worry about it, right? So now let us focus on the important aspect of this gear trains, right? So now in order to calculate the train value, you can go by whatever number of this power transmission has taken place. So you can start with this N5 by N4, right? Then N4 by N3, then N3 by N2, then N2 by N1. Now equal to again whatever this T4 by T5, then T3 by T4, T2 by T3, then T1 by T2, like that. So if you figure it out for this simple gear train, then N5 by N1 will be equal to T1 by T5, because here all the things will cancel out, N4, N3, and this T4, T3, T2, all the things will be cancelled out, and you will left with this N5 by N1 equal to T1 by T5. So once you have this, then this is your train value for simple gear train. If you observe here, only this driving gear and the driven gear at the end, only these two gears are deciding the train value. So all these other gears are idler gears in this simple gear train. So this is how you are having this simple gear train. And in simple gear train, when you are having odd number of shafts, then the direction of driver and driven will be same, and if you have even number of shafts, then the direction of driver and driven will be in the opposite direction to each other, right? So this is how you are having this train value for the simple gear train, right? If you go for calculating, yes,
Sir, you have said that the direction will be same in odd number.
in even in odd one, it will be same, na, for odd.
Sir, here they
If
are
you
opposite.
here,
1 and 5.
no, here we are having odd number of shaft, na. So if you see, the direction of rotation for one is this, na. So for 5 is also same this. Yes or no? It is
Yes.
same na?
Okay, sir.
Okay. So for the odd number of shaft it will be same, and for the even number of shaft it will be opposite to each other. Now if you go for compound gear train, then again you can find the train value as we have calculated for this simple. Here also you can find. So here it will start with this n6 by n5, right, and then n5 by n4, right. Actually here you are having more number of gears are mounted, right, on one shaft, so we need to consider that. So let us see what is happening. One is transmitting to 2, so n2 by n1 is equal to t1 by t2. Now 2 is not transmitting to 3 because 3 is already on the same shaft as of 2. So now 3 is running at the same speed of 2 and it is transmitting the power to 4. So n4 by n3 is equal to t3 by t4. Now the 4 is not transmitting power to 5 because 4 and 5 are also on the same shaft. So now 5 is transmitting to 6. So if 5 is transmitting to 6, then n6 by n5 is equal to t5 by t6. So once you have all this, again you can go for finding this train value, right, which is n6 by n5 into n4 by n3 into n2 by n1 is equal to t1 into t3 into t5 divided by t2 into t4 into t6. Now if you observe here, then 4 and 5 are on the same shaft, so this n5 and n4 must be same. 3 and 2 are on the same shaft, so n3 and n2 must be same. So for compound gear train value n6 by n1 can be given by this equation, right, t1 t3 t5 divided by t2 t4 t6. So if you see this t1 t3 t5 is nothing but the product of driving gears, because here 1 is driving 2, here 3 is driving 4, here 5 is driving 6. So in compound gear you are having this train value n6 by n1 is equal to number of this product of number of teeth on driving gears divided by product of number of teeth on driven gears. So this is how you can calculate this in case of your this compound gear train. Now in this reverted gear train you are having your this last particular shaft and first shaft are in means coincidence. If you can see the axis of shaft of that driven gear and driving gear are coinciding in case of reverted gear train. So that is how again you are having this particular compound gear, because 2 and 3 are on the same shaft, right? So for reverted gear train, if you write, then this particular n4 by n1 can again be similar to this compound gear train, like t1 into t3 divided by t2 into t4, right? But one more important thing in case of this reverted gear train is you are having this r1 plus r2 is equal to r3 plus r4, right? 1 and 2 are meeting here and 3 and 4 are meeting here, right? So this is how, because see here you are having this r1, here you are having r2, here you are having this r4 and this is r3. So in order to maintain this center distance, r1 plus r2 must be equal to r3 plus r4. So this is how you are having the characteristic of reverted gear train. It is generally used in some clock and sometimes in simple lathe, right, for back gear, right, in order to give speed to the chuck. So this is how this reverted gear train is used. Now the last one is this epicyclic gear train. In case of this epicyclic gear train, This one is epicyclic gear train. Yes, so for this we are going to use a tabular method in order to have idea about the different values or different speed of different components of this epicyclic gear train. So what you are going to do is you are having different what we can say component of this gear train. You are having arm A, right? Then you are having your the driving gear sun is your driving gear, that is assuming, and the P planetary gear is the driven gear. We are assuming this, right? Now we are going to consider different conditions. So if you consider that arm A is fixed, right? Arm A is fixed, right? Means it is not going to provide any motion, and you are providing +1 motion, or we can say see, this A is fixed, so whatever speed of arm A is 0, right? And you are giving +1 revolution to S. What we are going to do is we are going to consider this counterclockwise as positive, and this may be going to rotate clockwise because of external gear, right? Because of external contact, if this is moving in counterclockwise, then this will move in clockwise. So if this is having this +1 of revolution, then what is going to happen to this speed of P, right? You are having this ns by np, right? Sorry, yeah, or we can directly write np by ns is equal to ts by tp. So here you have assumed ns as 1, so if you find np, then it is 1 into ts by tp, right? So the speed of this will be coming 1 into this ts by tp, but as the direction is clockwise, we will consider it as -1 into ts by tp. So here -1 into ts by tp is you can consider it in other terms as whatever speed is there of this driver into that number of teeth on driver divided by number of teeth on driven. So this is how you have written the first row in the tabular method of this epicyclic gear train, right? Now if you consider again that arm is fixed, right? This is arm, again arm is fixed, right? And you are providing some x rotation, then it will have this x into ts by tp. Now you are adding the motion to arm itself. You are providing, let us say, +y to arm, right? So that will be directly added to the remaining component, that is +y plus x and +y minus x into this ts by tp, right? So this x into ts by tp. So this is how you are having this particular motion or rotation of different particular component of your epicyclic gear train. So this will help you solving the problems on this epicyclic gear train. Once you have all this data with you, then you can consider in terms of whatever number of revolution these components are having per minute in whatever direction. So if you consider that data, then you can calculate the speed of different components of that particular epicyclic gear train, right? So this is how you are having your different types of gear train. So once you are done with this, then there is a what we can say simple numerical I have taken from that SS Ratan, right? For this
Sir, one thing I have to ask you, that is epicyclic gear train is known as a sun gear train.
Sun and planet, I guess. Sun and planet gear train, right? Yes.
Okay, sir.
Okay. So here
And sir, one more thing I would like to tell you that at the beginning, at the earlier stage, I missed something due to my network issue. So, could I get that PPT and some of the lectures like to clear my concept?
Yes, yes, that will be provided,
Okay, sir. Thank you, sir.
right?
Thank you. Okay, okay.
So here voice is not audible, it is mentioned like that. Can you hear me?
Yeah, you are perfectly audible, but at the meantime, your voice was coming low to us.
So right now is it coming properly?
Yeah, now it's audible, perfectly audible.
Okay, okay. So now let us go to the, what we can say, the solving this simple question, right? So here what you are provided is epicyclic gear train, right? And you are having this arm A, and you are having gear A and B, which is having number of teeth 30 and 40 respectively, right? Then the arm rotates about the center of this gear A at a speed of 80 rpm counterclockwise. What is provided is this counterclockwise speed of this gear A is provided, right? And you have to determine the speed of the gear, right? Gear B, right? You have to determine the speed of the gear B. Now you are provided two different conditions. One is gear A is fixed, and the other is gear A also revolves at 240 rpm clockwise. So first what we are going to do is we are going to make the table, right, what we have made earlier. So we are having this arm, then your gear A and gear B. So first is this 0, then +1, then -1 into TA by TB, right, because it is driver upon driven. Then we can again give this, right, TA by TB. We can put the value of TA and TB. Now then at the end this plus y plus x, and then plus y minus x TA by TB. Now once you have this table ready with you, then you can go and put the different values, right? The arm rotates about the center of the gear A at a speed of 80 rpm counterclockwise. That is this, right? Arm speed is y, and it is plus 80 only because it is counterclockwise. So y is given as plus 80. Now if you consider the first case, right, then gear A is fixed, which is y plus x. So if y plus x is fixed, right, then y, you already know what is y. Y is plus 80. So if you know this, then you can calculate that x is minus 80. So once you know this x and y, what you can do is you can calculate the speed of gear B. Speed of gear B is equal to what? Plus y minus x TA by TB. Now plus y is 80 minus x, that is minus 80 into number of teeth on A is 30, number of teeth on B is 40. So once you simplify this, you will have 80 plus 60, that is 140 rpm, and it is coming positive. It means it is counterclockwise. Similarly, if you go for the second case which is mentioned here, in that what is mentioned is gear A is revolving at 240, that is y plus x, and that too at clockwise, so it is minus 240 because it is clockwise. Now x is minus 240 minus 80 because y we know, y is not going to change for case 1 and case 2. So that is why this x is minus 320 rpm. Now once you are having this value with you, again you can calculate speed of gear B. Speed of gear B with the same equation, that plus y minus x ta by tb. So this plus y is nothing but plus 80, right, as we know. Minus x is now minus 320, right, into this 30 by 40. So once you simplify it, what will you get is 320 plus 320. So this is again counterclockwise direction. So this is how you are having your this different gears and gear trains concepts. So once you are done with this, then you can start solving problem on this. Right now this is the problem from this gate 2004, right? So you can see on this particular screen, can you see the screen and question?
Yeah,
So can you try?
it's visible, sir.
Yeah, so can you try for the first one?
Okay, sir.
Try it and type in your answers, huh? Okay. What is arm? Arm is actually holding the both the gears 1 and 2, right? So somebody has asked what is arm. So now let me generate poll only, right? 1 second. Gate 2004 question 6. 1 second.
It would be 60, sir. 60.
60. Okay. So can you see that poll?
Yeah.
Poll.
Yeah, poll is visible, but
Yeah.
could you please show me the options?
Option D is the correct one, huh? Hello.
Yes, sir. Yes.
Everyone is
Six.
everyone is getting the same.
I hope so.
Let me check whether answer is there. You can type in your answer through poll also, right? Then I should end the poll. Please answer through poll, those who got the answers. Hello.
Submitted, sir, on the poll.
Okay. So I'm ending the poll. Now those who have answered correctly, right? But many of you have not answered. So let us see what is provided here. Two meetings per gears have 40 and 120 teeth respectively, right? And the pinion rotates at 1200 rpm and transmits torques of 20 newton meter. The torque transmitted by the gear is now.
Sir, your voice is coming low to us.
Okay.
Could you please
No.
be a bit loud for us?
Now
it's
no.
perfect.
Okay.
Now it's perfect.
Okay.
Yeah.
Yeah. So here.
Pardon me for interrupting.
Thank you. Now you are having this number of teeth on pinion as 40 and number of teeth on this gear as 120, right? Once you have this, you are provided speed of pinion, that is 1200, right? So you are asked to find the torque, but in order to find the torque, first you have to idea about the speed of the gear. So your speed of gear ng by np is your this tp by tg. So your ng is equal to np is 1200 into tp is 40 into tg is 120.
120.
So you will get 400 rpm, right, as your speed of gear. Once you get the speed of gear, then power transmitted will be same as we have mentioned earlier. tp omega p is equal to tg omega g. So once you have this, then your 2 pi np by 60 into tp is equal to 2 pi ng upon 60 into this t g, right? Now if you give further simplification, then it is nptp is equal to ngtg. So np is with you only, right? That is 1200, and you have tp also, that is 20. You have ng also, that is 400, and tg you have to calculate. So if you simplify it, you will find 60 Newton meter. So if you observe, the gear is providing more torque, right? This is the answer D, as we have discussed earlier, that this is how this what we can say, we are using this gear drives in order to have increased torque. Now can you try for the next one? This is easy, right?
Yes, sir.
So please try to answer this. Write ABCD in chat box only. Or let me generate poll only. 1 second. I'm generating. Yes, P is the correct answer. Somebody has written it correctly. Yes, you can answer in that pool I have generated. Can you see that pool?
Yeah, already done this, sir. B.
Okay. Okay, so now I'm ending the poll. Okay. So now as you can see here, this B is the correct answer. So I guess it is simple. Bevel gears are non-parallel, non-intersecting shaft. Then this worm gear is non-parallel. 1 second. Okay, yes, non-parallel, non-intersecting shaft. Then R is given as herringbone, parallel shaft, correct. And then this hypoid gears, correct, as non-parallel and offset shaft. Okay, correct. So this is how you are having your this second question. Now if you go for the next one, then here you are having this question. Here it is saying that a compacting machine shown in the figure below is, yes,
Voice is little low, sir.
oh sorry, a compacting machine shown in the figure below is used to create a desired thrust force by using a rack and pinion arrangement. The input gear is mounted on the motor shaft, right? The gears have involute teeth of 2 mm module. Now you are asked to find the what we can say torque required on the input shaft to create 1000 Newton output thrust, right here as it is mentioned. So first let us do that only. So here I guess let me first give you some input, right? Because here you have to first draw this free body diagram, right? And here in this you have to generate that 1000 Newton thrust, right, by this particular drive. Right here you are having this omega 1 and omega 2, right, and through this you have to generate the force of 100 Newton. So the very first thing is here you will have 2F is equal to not 100,000 Newton. You will have this 2F is equal to 1000 Newton. So F is equal to 500 Newton. Now as the efficiency is given as 80%, whatever power generated, right, with T1 omega 1, only 80% of that will be transferred to this T2 omega 2. Here actually you will have two different gears, right, as you can see in the figure. So here T1 omega 1
Sir, 25 Newton meter, sir. The answer would be.
yes, correct, good, right. So here T1 omega 1 into 0.8 is equal to 2 T2 omega 2. So in this what you have to calculate is T1, right? So T1 is equal to 2 into this T2 torque is nothing but the force into the radius, right? Radius is T by 2, right? And here again omega 2 by omega 1, right, and divide by 0.8. Now this D you have to calculate from the module, right? This D you have to calculate from module is given as 2 mm and number of teeth is 80, so you will have 160 mm as the diameter. So now you are having all the values with you. 2 into 500 into 0.16 divide by 2 divide by 0.8, right, into omega 2 by omega 1. Now omega 2 by omega 1 again can be calculated from the ratio of teeth, right? That
Teeth, yes, sir.
yes, ratio
Sir,
of teeth will
at
give
the beginning, it's
this what we can say omega 2 by omega 1. T1 is given as 20, T2 is given as 80. So omega 2 by omega 1 is nothing but 1 by 4. So now you are having all the things with you. So what you can do is when you simplify it, you will find that the answer will be 25 Newton meter, right? So this is how this 2 can be cancelled, right? Then here you can have 0.8 into this 0.2 as 0.16, and then 0.2 multiplied to 500 will give you 100, right? And then when you divide it by 4 you will get 25, right? You can verify it. So your answer would be this one. Now here, if the pressure angle of the rack is 20 degree, the force acting along the line of action between the rack and the gear teeth. So for that we are having a relation, and that is nothing but this P cos theta is equal to F, right? So once you use this, you can also
Yes, sir.
find this like P is equal to F upon this cos theta, where your theta is given as 20.
It's 532 Newton.
So
sir.
it
The
will
second
be 532 Newton, correct. So this is how you can solve this kind of question. Right, now when you go to the next one, then here it is simple, right? You can type in your answer in chat box quickly, A, B, C, D. You can see on the screen this question number 29, right, from this 2006. You can quickly type in your answer in the chat box. Has anybody answered?
Yes, sir. B.
Answer is B, huh? So are you sure? What are the others have written?
Sir, no, sir. It would be 140 mm, sir. 140
No,
mm.
no, no, no. I am asking about this one, na? 29, question number 29.
Oh,
Yeah, so answer is B, I guess. Many of you have written it correctly only. So addendum is related to gear, then this instantaneous center of velocity will be to linkage, then section modulus will go to BIM, right, and then prime circle will go to chem, correct. Now go to that next question, right, this one. So now please try.
that would be,
Huh.
I think, 140 mm. 140 mm.
Correct. So it is also a simple question. What you are provided is number of teeth, right? You are provided number of teeth
Yes, sir.
on pinion and gear, TP and TG. So what
And
you are
then
asked is
at the end of
center
the
distance.
center
that
of
is
distance, we have to
nothing but
calculate center of distance.
dp plus dg by 2,
Yes,
where
yes, sir.
dp is
2,
nothing
yes, sir.
but m into tp and dg is nothing but m into tg. So you are provided this module m, right? So dp will come 5 into 19, that is 95, and this dg will come 5 into 37, right? That is 185 mm. So when you put this dp plus dg by 2, you will find it as 140 mm. Right, so it is also a simple one. Now let us go to the next one. Yes, this one. Now here actually I have to write questions like this, side by side. So there are two questions. So you are provided this what we can say, gear drive, right? Epicyclic gear drive, as we were used to make a table, right? So in that you are having the 4 gears now, right? Gear 1, 2, 3 and 4. Carrier 5, you can consider it like that what we can say, arm, right? Which at the end you can consider relative to that only, your omega 1 or omega 4 or whatever. So what you have to do is you have to prepare table with the gears 1, 2, 3 and 4, right? And you have to have this kind of what we can say, that let us say gear 1, 2, 3, 4, then you can write number of teeth of gear 1, 2, 3, 4 in your table, and then you can start making that speed as we have done for the previous example. I would like you to try it by yourself, right? Try it and type in the option for question number 74. What will be the correct option for question 74? I am giving you 1 minute. It will take time. So please all of you try to solve this question by yourself. Is it possible for you to try? Hello? Can anyone unmute and say me? Tell me.
Yes, sir. Yes, sir. Just give some moments, sir.
Yeah.
Just give some moments.
But you please try, all of you.
So please show the question.
Yeah.
Sir, would it be omega 1 minus omega 5 by omega 4 minus omega 5 equal to 6?
Correct. So anyone else is getting that answer? Sorry. Anyone else is getting the answer? So let me write now number of teeth on this 1 2 then 3 and 4. So these are number of teeth. So if you provide this plus x to 1, then to second one it will be minus x into driver upon driven, that is 1 by 3. I am directly writing 15 by 45 as 1 by 3. Now again the 3 is also rotating at the same, right, x into 1 by 3, or let us say minus x by 3. When it is going to transfer to that gear 4, then it will be sign change, because again external gear, so plus x by 3 into again driver upon driven, that is 20 by 40, that is 1 by 2. Now if you add this y to all of this, then y plus x, y minus x by 3 minus x by 3, here plus x by 6. So if you go for this omega 1 minus omega 5, omega 5 can be considered as your arm, right, for which you can consider only y,
Yes, sir.
right? So omega 1 minus
Y, yes.
omega 5, omega 4 minus omega 5, that is y plus x minus y divided by this y. Here also I forgot to put y, here and here, sorry. So y plus x by 6 minus y. So when you simplify this, you will have x divided by x by 6, which is nothing but 6. So this is how you will have your answer. Now I guess the second one you can try, everyone, right? Question number 75, because you are already having the speeds of 1 2 3 and 4 with you, right? Am I correct? Hello?
Yes, sir. Yes, sir.
So,
Yes, sir. Yes, sir. Yes, sir.
So please try the question number 75 and tell
Okay,
me.
sir. Doing it, sir.
Yes,
Sir,
yes.
just give me 2 minutes.
Yes, please.
Sir, minus 156 is coming, sir.
Minus 1, it should be plus, actually, counterclockwise should be plus. Let
60 by 60 minus omega 5 by minus 120 minus omega 5 equal to 6.
let me see.
I mean,
let
I'm
us
telling
see.
you that.
Yeah. Let us see. Y plus x is provided as minus 60, because here it is clockwise, right? So for omega 1 is equal to 60 rpm clockwise. When looked from the left, what is the angular velocity of the carrier and its direction, so that gear 4 rotates in counterclockwise direction at twice the angular velocity of gear 1 when looked from the left. So your omega 4 is twice the speed of 1, right? So that speed of 4 is twice the speed of 1, right? And here again it is counterclockwise, so we will write it as negative y plus x by 6, it is omega 4. Now it is a here it is counterclockwise, so here 2y plus x, right? Now, right, so here after that this, see here it is when it is okay, so y plus x by 6 is equal to this minus 2x plus y. So after that, if you give further simplification, minus 2y minus x, then y can come on this side, x 2x plus x plus 6, that is 13x by 6 is equal to minus 3y. This 2x can come this side, this y can go this side, so 13x by 6 can be equal to minus 3y. So here your x is nothing but minus y minus 60 from this condition, right? X is nothing but minus y minus 60. So if you put this minus y minus 60 divided by 6 equal to minus 3y, sorry, equal to minus 3y, then when you give final simplification, your y will be coming plus 156. Can you check now? From this y can be your plus 156, so that is why counterclockwise. So can you see this one, everyone?
Yes, sir.
Right. So
Yes, sir, but it's coming minus 156.
I don't know, you may have missed this notation, right? Check that, otherwise we will see. Okay, now let us go
Okay, sir.
to the next one. Yes, so for the next one, this is a gear set has a pinion with 20 teeth and a gear with 40 teeth. The pinion runs at 30 revolution per second and transmits a power of 20 kilowatt. The teeth are on the 20-degree full depth system and have a module of 5 mm. The length of the line of action is 19 mm. Now the center distance for the above gear set in mm is, can you calculate the center distance first? What is center distance? We have calculated earlier also, right? Diameter
Yes, sir.
of pinion
It's-
plus diameter of
It's
gear
like
by
the
2.
average by 2. By 2.
So here also you can easily do this, right? Because module is given as 5
Yes,
mm.
sir. I can do that. I can do
Yes.
that.
Please calculate and tell me. Number of teeth for pinion and number of teeth for gear is given. So diameter can be calculated with m into t. Everyone can calculate.
It's 150.
It's 150. Yes, correct.
It's 150.
Everyone must be
150.
getting this. Okay. Now contact ratio. Remember contact ratio. What is contact ratio?
Sir, as it seems like 1.25.
Sorry.
As it seems like 1.25 as the answer is has came 150 as what the
Answer is 150 only,
as
na?
answer.
So what are you asking
Yes,
actually?
sir. Answer 150. Actually, I am telling you the contact ratio. Since 1.25, the answer might be.
No. Let us see. It is not that one. Contact ratio is what?
Okay. Then calculate.
Arc of contact.
Arc of contact divided by circular pitch.
Arc of contact divided by circular pitch. Right. Arc of contact is what? Path of contact divided by cos 5 divided by pi m, right? Circular pitch. So now if you simplify this, path of contact is given right here, line of action, this path of contact 19 mm divided by cos phi 20-degree full depth system is given. So 19 divided by cos 20 divided by pi m will be your answer. Please tell me what are you getting as your answer. Can you tell me the answer? Hello.
Yes, sir, we are calculating.
Please calculate.
One 1.29, sir.
1.29 is the correct answer. Yes, good. Right. Now for the last one, resultant force on the contacting
One would be
gear strength. For that I have given you this hint, right? For that last question, question 73, I have given you this hint. Can you calculate?
Yes, sir. Actually, after calculating, it would be 2 to 5.80.
225.80.
Yes, sir.
Correct. It will be like that only. So first what you have to do is power is equal to torque into that rotational velocity T omega, right? So T will be equal to P into 60 by 2 pi n. So once you do this, you will find your torque, that is 106.157 Newton meter. So once you have this torque, you can find that Fr, which is generating this torque, right, by Fr is equal to torque upon that radius of pinion, right? So that radius of pinion we have already calculated earlier, right? So this will give you the Fr value, that will be 2123.14 Newton. So once you have Fr, then what you have to calculate is this particular F, right? So if you have Fr, right, then you can if you have this Ft, you have calculated Ft, because torque is generated with this Ft only. Sorry, this is your Ft only. So once you have that Ft with you, you can easily calculate this F, because this Ft cos phi, sorry, this F cos phi is actually the value of this Ft, right, which you have already calculated. So as you have Ft, you can calculate this Ft, you have this 2123.14 and cos 20 is there. So this Ft divided by cos 20 will give you 2258.1, right? So this is how you will get your answer. So once you are done with this, then you can go for this one. Again, this is very simple. You can directly type in
Sir, your voice is coming bit low, sir. Sorry, sir.
Okay. Now is it audible? Hello. Now.
Yes, sir. Now it's perfect. Yeah.
Okay. So you can quickly type in your answers for question 43 from this GATE 2008. It is simple only. So please type in.
Would it be B?
Sorry.
P1, Q4, R5, S6.
Helical is not there for non-parallel, non-intersecting, na?
Oh.
Right.
Yes, sir.
Right. So has anyone got the answer?
P4.
For helical it is
Sir,
axis parallel
As
and teeth are inclined to
Yes,
the
sir.
axis for helical, right? For spiral
Okay.
bevel, axes are perpendicular, right, and
Yes,
intersecting,
sir.
and teeth are inclined. So in that bevel you are having this spiral bevel and zero bevel and all variation are
Mhm.
there, right? So for R it is actually one hypoid, it is non-parallel, non-intersecting axis, right? And for rack and pinion, axis parallel and one of the gear has infinite radius that we have seen earlier. So A is the correct answer. Now if you go for this question number 62, then one tooth of a gear having 4 module and 32 teeth is shown in the figure. Assume that the gear tooth and the corresponding tooth space make equal intercepts on the pitch circumference, right? And the dimensions A and B respectively are close to this one. So what given here is, you are given the module, you are given number of teeth, you are given that the gear tooth and the corresponding tooth space are making equal intercepts right here. So now what you have to do is, you have to first calculate the value of this particular what we can say A, right? For A, if you start thinking about A, then it can be available from your pitch circle diameter, that is PC, that is pi d by t, right? So pi d by t means pi m. So m is 4 and pi is 3.12. If you consider, then it will be around 12.56. So this the circular pitch is basically a point on the tooth to the corresponding next tooth, right? Like this, the same point on the next tooth. So this is tooth thickness, and here this is tooth space from here to here. This is tooth space. So this both are same, right? Here as it is A, this is also A, and what you have calculated is the distance from here to here. So actually this 12.56 is nothing but 2A, right? So if 12.56 is 2A, then your A will be 6.2A, right? So A you have calculated. Now in order to calculate B, what you have to do is, you have to calculate first this distance OP, right? If you see this figure, this that is why this hint is given for this particular question, right? So here, if you before even going to that particular what we can say OP, if you first find this angle sine phi, right, then this sine phi can be given with this PQ upon OQ, right, where PQ is nothing but your this pi, right, and
So answer would be D.
answer would be
6.28 mm
D, yes.
and 4.1 mm.
yes, correct. So for that you are having this 64 mm, right? So once you have that angle of phi, right, that you can calculate as 2.81 angle. So once you calculate this angle, then OP is nothing but this 64 cos phi. OP is nothing but 64 cos phi. So once you calculate the value of this OP, then you have to calculate this PR, because from here to here addendum is generally provided as 1 into module, right? Whatever this distance is there mentioned as addendum, 1 into module. What you have to calculate is this RP, right? So what you have to calculate is this RP, that is nothing but OR minus OP. RP is OR minus OP, right? So when you calculate this OP and put it here, your OR is already known to you as 64, right? That radius. So what you will be able to do is you will be able to calculate RP as 0.1 mm. So now RP is 0.1 mm and your addendum is 4 mm. So when you add this RP to this addendum, then you will find your B, right? Your addendum plus RP. So this is how you are having your answer. D is the correct answer. So now let us go for the next one. So this one, this I guess you can try, right? In this epicyclic gear train, we can see the data given as the sun gear is the gear 2 on the input shaft, and it is having 20 teeth, right? And it is external gear because it is in mesh with 3. So the planet gear is 3 is a 40 teeth external gear because it is in mesh with 2. Now the ring gear 5 is a 100 teeth gear, and it is internal gear because it is in mesh with 3 as internally meshed gear, right? Now the ring gear 5 is fixed and the gear 2 is rotating at 60 rpm counterclockwise, right? The arm 4 attached to the output shaft will rotate it. So this again you can calculate by making a table. So can you make a table and solve this question? Hello? Hello?
Yes sir, yes sir, yes sir, yes sir, yes sir.
So
yes,
please
sir.
please try this
Yes.
one. Please try this one.
Okay.
Go ahead.
Sir, I don't know how to make table, sir. Will you help me?
In that case I can give you a little bit of hint. 2, 3 and 5 are the gear, right? You are having motion of this 3 gears. 20 is the number of teeth on the gear 2, 40 is on 3, and 100 is the number of teeth on gear 5. So once you know this, then you can start with this plus x to this 2, then this minus x into the 20 by 40 number of teeth on driver upon driven, so that is 1 by 2, right? Now here when you go from 3 to 5, the direction will not change, so sign will be as it is, minus x into this 1 by 2 into again number of driver and number of driven, so 40 by 100,
2.5.
right? So this way you can add plus y also here. So write plus y plus x, then plus y minus x by 2, then here plus y minus this
10 sir, 10.
x by 5, no? Minus x by 5
Sir,
mostly.
Sir, answer 10 RPM.
Answer is 10 rpm. Yes,
Hello?
correct. But counterclockwise
10.
or clockwise or counterclockwise?
Clockwise.
Check again.
Oh, sorry, would be counterclockwise. Option A.
Right, so A is the correct answer. Why? Because here y minus x by 5 is given as 0 because that gear is fixed. It is mentioned, right? Ring gear is fixed. For ring gear you are getting y minus x by 5, that is 0. So your y is equal to x by 5. And what is x? X is given, I guess, right? I guess
60.
no, x you have to first derive x, right, from this 60 rpm counterclockwise, this gear 2, na? So this gear 2 is having this y plus x.
X would be 50.
So y plus x, yes, is equal to 60 degree counterclockwise, so positive, right?
Yes, sir. Yes.
So now y is equal to x by 5. So if you put x by 5 plus x is equal to 60. So if you solve this, then it will be 6x, right? is equal to 60 into 5, correct? So x
Yes,
is
sir.
equal to 50, and that is positive, it is again counterclockwise. So now y is equal to 50 by 5, and it is positive only, right? So that is positive only, and positive is counterclockwise, correct? So everyone is getting now what you have to do.
Yes, sir.
So this is how you are,
Yes, sir.
yeah, this is how you are having your this particular question, right? Now the
Yes.
next is this one. So here again the same kind of question is there, but they have provided the different view, right? So what you have to do is, first you have to make this particular view in which it is more visible to you which gear are in connection to which gear, right, and how internally and externally meshed they are. So if you consider this is your gear 2. Let me draw it again, right? If you consider this as your gear 2, then it is in mesh with gear 3, right? And you are having one more gear 4 on the same shaft as of 3, right? This is gear 4, this is gear 2, this is gear 3, and this is gear 4 which is on the same shaft of 3, and then you are having this gear 5 kind of ring gear which you have earlier also, right? So this is your gear 5. So now once you have this kind of diagram, then you can again start creating table for this gear 2, 3, 4 and 5. Number of teeth are given, right? Yes, 20, 24, 32 and 80. So can you solve this one?
Yes, sir.
Please try and solve.
Okay, sir.
Yeah. So what is provided is this omega 2 100 radian per second clockwise, omega arm 80 radian per second counterclockwise, and this omega 5 in radian per second that you have to calculate. Beware, here you are having internal contact between 4 and 5, so over there sign will not change. Okay.
Yes, sir.
Okay, sir. So that will be 140.
140 clockwise or
Counterclockwise.
counterclockwise? Yes, correct, right?
Counterclockwise.
Yes, correct. So here again you can go by the same, plus x, then minus 20 by 24 into x, then 3 and 4 are on the same shaft, so again minus 20 by 24 into x, and then when it transmits power to 5, that sign will not change, minus 20 by 24 into x into again driver upon d1, that is 32 by 80, and then you have to add y, right? Y plus x, then y minus pi by 6x, then y minus again pi by 6x, and then y minus this x by 3, I guess, y minus x by 3. So now when you put the values you will get answer. I am not now doing it because you all know it now. Is it fine?
Yes, sir.
Okay, so let us go to the next one. Yeah, so this is something different, right? So the following data are provided for two crossed helical gears, right, for speed reduction. Gear 1 is having pitch circle diameter in the plane of rotation is 80 mm and helix angle 30 degree. Then gear 2 is having pitch circle diameter is 120 mm and helix angle is 22.5 degree, and input speed is 1440 rpm. So you have to find the output speed. So for that, actually you are having, in case of this helical gears, n1 by n2 is equal to d2 by d1 into cos beta 2 by cos beta 1, right? So when you put all the values are with you, right, except n2, because d1 and d2 are given, beta 1 and beta 2 are given, and input speed n1 is given. So when you give simplification, you will find your n2 is almost about 900 rpm, right? So your correct answer will be this 900 rpm, right? So let us go to the next one
Yes, sir.
quickly. Yeah, yes, this one. Can you try and solve this one?
Yes, sir.
Here compound gear train with gears P, Q, R and S has number of teeth 20, 40, 15 and 20 respectively. That gears Q and R are mounted on the same shaft as shown in the figure below. Now the diameter of the gear Q is twice that of the gear R. Then if the module of the gear R is 2 mm, the center distance in mm between gears P and S that you have to calculate. Sorry,
80, sir.
all of you are getting
B of option B.
all of you are getting the same.
We are trying, sir.
Calculate it.
Not able to get, sir. About module of Q.
So module of Q you have to calculate, na?
Okay, sir. Ji, sir. Is it B, sir?
Yes, yes. How many of you are getting this answer? B? All of you are getting the same answer? Because see, here what you have to first do is module of R is only provided, right? Module of R is provided as 2 mm. When gears are in say meshing, then module will be same. So for S also it is 2 mm. But for Q you don't know. So for that, what is provided? Diameter of Q is twice as that of diameter of R, right? And what is the diameter? That is M into T. So 2 into MR into TR. So from this MQ you will get as 1.5 mm. Similarly MP also will be 1.5 mm. And the distance between P and S is actually this radius of P plus radius of
Sir, we can't
Q.
hear you properly.
Hello.
Now it's
Okay,
yeah.
okay. So now radius of P, radius of Q, radius of R, and radius of S. Now radius is again this mt by 2, right? So mptp by 2, mqtq by 2 plus this mrtr by 2 and msts by 2. So mp and mq are same, right? 1.5 in bracket tp plus tq by 2, that is 20 plus 40 by 2, plus this mr and ms are same as 2, right? And again 50 plus 20 by 2. So when you now give simplification, you will find your answer is 80. Clear? Hello?
Yes, sir. Yes.
Okay, okay. Now for this one, yes, this one, I guess for this is easy, right? I guess for both of this you can calculate
Yes, sir.
and then get answer. I guess you can take this print out, means screenshot for your practice, I guess,
Yeah.
right? So this is
This
from
one is
2014 session
Can
1
I
and
kindly go to
session 3,
previous slide?
right? So this both you can try by
Excuse me.
yourself. Hello?
Sir, can you kindly go to the previous slide for me?
Okay. This one?
Yes.
Yes. Is there any doubt?
I just wanted to screenshot.
Okay. Now, yes, this two both you can try by yourself. These are easy only. Based on previous question, you can solve this one. Have you taken screenshot for this one?
Yes, sir.
Okay.
Sir, sending a PPT is useful, sir.
Yes, I will share. This is the last this slide, 2014 session 4. It is easy only. This is also, right, which will convert rotational
Yes,
to
sir.
translation. This is
Rack and pinion.
rack and pinion only, right?
Yeah.
And here this is something different, but as we have discussed, you can calculate it from this or you can derive your answer from that one, that what will happen when your this particular speed ratio is going to be increased on the minimum number of teeth. You have that relation, right? On pinion T minimum,
Yes, sir.
you have that relation, right? T minimum is equal to this 2 into addendum of pinion divided by this 1 plus G, sorry, one plus G plus 2, right, sine square phi, right? So when you consider this, you have minus 1 actually, right? So when you consider this equation, what will happen is whenever this speed ratio is going to increase, right, your this gear ratio will go down, this capital G will go down, and as capital G is go down, your this number of teeth is going to increase, correct? Hello?
Yes, sir.
Okay, so this is how we have seen this gear and gear trains.